Good morning, good afternoon, good evening. Welcome back to Coding Scientist. Alright guys, so in this video, it's going to be really exciting, right? So I'm going to show you how we trained our humanoid robot with our customized visual language action model. So it's a pretty much our own solution to make the machines work with our own inbuilt large language model as well. So using the VLA, the Vision Language Action Model, we trained our humanoid robot to recognize specific color of an object, any object. You can talk about a mouse, which is black color, or you can talk about, say, my iPhone, which is blue and black, and stuff like that. So you can basically train an object and trigger the robot's palm, these palms, and the gripper. So basically what's going to happen is, guys, it's going to get really interesting as we move forward with further projects. So when we show an object in front of the robot, right, so robot's camera, so it's going to recognize a color and the object as well, both combination of a color and an object. It's a tricky stuff, right? And then the gripper actually is going to hold that particular object and place it in a different position where depending upon how we program it, right? So where you want the robot to take the object and walk forward or walk towards the side or walk towards reverse or on the right side and place it somewhere else, or make it autonomously where you can define that robot to take the object and move around your house and place the object in a specific area. So everything is possible using the Vision Language Action Model. So using our custom built LLM, we can actually train the robot to recognize any kind of objects of any color and trigger logic based ROS topic for the robot to carry the object in any environment. It can be indoor or it can be outdoor, right? So basically what we try to do is we programmed and implemented purely based on ROS node, robot operating system, basically facilitating the communication and coordination between the nodes through the publication and subscription of ROS message and services. So overall, if you see, guys, this program demonstrates how to utilize a robot's sensing capabilities and mobility, as well as the communication aspects, right? So that's the power of implementing LLM in robotics area. So let's take a quick look at the demo, and I'm going to just connect to my bot. I hope I'm connected. No, I don't think I'm connected. So let me just connect it now. Right. My password to the terminal. Okay. And boom, so the basic service, I'm able to connect to the bot, and now I need to up the service. So let me just put in the command, the terminal command here. Alright, so it's basically sudo system control start the up and hit enter. Alright, I don't see any error, so that seems to be working fine. Now let's look at this. Now let me launch the ROS topic for this particular functionality and see what happens. Alright, there you go. Okay, cool. Alright, the service seems to be running and the bot is moving. Can you see that? Okay, the head is tilted towards the displacement area, which is at the bottom. Now if you let me just open up the browser and alright, there you go. Okay, so on the browser, if you see carefully, guys, you can see a square mark, right? So that's where the bot is actually visualizing. So for the demonstration purpose, I have just trained about two different colors, just a sample. One is red, one is blue. It's just a thermocol cube, just for the training the model and showing the demonstration. And then we'll take it forward with multiple other objects to be trained. So let's take a look. Now I'm going to place one of the objects into the square square box you can see on the web browser on the right hand side. The web browser is nothing but it's a robot's visualization. So the robot's eye is looking at, you know, a specific area. So I'm going to place a red color within the square mark. There you go. Can you see, guys? Alright. Now I'm going to place the blue color as well. There you go. Fantastic. So I can actually lift it on top and see if it's going to hold the cloth. Okay. It has to be within that square. Boom. Wow. That's interesting. Now I'm going to place the red color, and you can see on the terminal, guys, if you see on the terminal on the right hand top of the screen, it shows red and blue. So it detects the color, recognizes the color, and it pours the color into the topic. So that's pretty interesting, isn't it? Okay, so this is a pretty short demo on how you can basically, you know, build your own object recognition models using our VLA. So you can actually add billions of parameters. However, the challenge is, you know, we are using a very tiny computer called Raspberry Pi. Though these models are trained and connected to our AWS cloud, but the processing speed, it pretty much requires a very high intensive GPUs. So over a period of time, I'm planning to replace Raspberry Pi with Jetson Nano or Jetson Orin, you know, which has got a GPU-oriented stuff. So that's going to give us a better performance. Let's see. Right now we are on a demonstration stage. We are building this product further and doing a lot of R&D. I hope you enjoy, guys. If you need one-on-one help, do reach out to our subject matter experts in coding scientists, and we will be sharing you all the source codes and step-by-step instructions, how to install, how to assemble the robot, how to configure it, how to set it up, everything end to end. See you soon. Goodbye.